All right, well, thank you, Roshan, for that introduction. Good morning, everyone. I'm honored to be here today to talk to you all about swine nutrition. We could certainly spend probably 2 days talking about what we're doing in amino acid research in swine, so this is going to be very condensed. Some of it might be a little bit of a review for some of you in the room, but then we'll get into some of the more important information about what we're currently doing and some of the things that we're thinking about as we're going through the process. So when we think about swine diets today in the United States, much like poultry, the current source of protein that we're seeking will be soybean meal. And over the last 20, 30 years now almost, we've seen this fluctuation in soybean meal prices, and certainly it is elevated. And what we have also seen is the introduction of feed-grade amino acids coming into play. And as those feed-grade amino acids have come in, we've been able to pull down our crude protein levels and start feeding more synthetic or feed-grade amino acids. One of the things I want you to think about as we start thinking about pigs, what we look at is as that pig matures, we're going to see shifts in crude protein levels in the diet. They're certainly going to reduce as time goes on. This is partly related to feed intake. Pigs, when they're first weaned, are only eating maybe 0.1 kilos a day. By the time they go to market, they're over 3 kilos a day, almost 3.5. And so significant increases in feed intake change how we think about formulation. But then more importantly, as that pig matures, we do have to go through a finishing phase where protein accretion starts to lower and we get some fat accretion shifts. And so again, when we think about feeding a pig, we're kind of thinking in different phases, and that's going to influence how we think about amino acids in our diets. So as I mentioned, we've had this introduction of feed-grade amino acids, but it's not just one, right? We're down to, we could probably list them all, but multiple amino acids that we now have at our disposal to start to use. And so as we start to pull those amino acids in and replace soybean meal, we can shift our costs significantly. So here's an example. Last week I pulled some diets. I just reduced crude protein by about 2% in the diet, and I was able to save about $1.10 a ton, or in pig terms, we were saving about 37 cents a pig. So pretty significant shifts in our ability to save some money. But in addition to that, what we also see is as we reduce that dietary crude protein, we're reducing the excretion of nitrogen by about 8.5%, right? So every 1%, we're thinking about that 8.5. And certainly the word sustainability has really started to come into play, as you all know, in the last few years. And so we are thinking about that as well. And so our group is actually doing some research today to better understand gas emissions associated with the use of feed-grade amino acids. So here, for example, is a study that was published a while back, actually last year, that shows that as crude protein in swine diets goes down, we see this reduction, pretty much a linear reduction in ammonia production in the manure, right? We would expect that. That would be very common. The other piece that we look at, particularly in emissions, would be hydrogen sulfide. And so hydrogen sulfide has a little bit of a unique situation where it's fairly plateaued for a bit, and then we get a pretty significant drop in hydrogen sulfide production as we go below 17% crude protein in the diet, and then we kind of come back down and we kind of start to plateau again. But again, as we think about some of the other components, when we think about gas emissions in relationship to livestock production, these are areas that we really want to focus on. Within our own group, we currently have a study going where we're working with high soybean meal diets. Right, so as we think about biodiesel production coming online, there's a lot of conversation in the swine industry that we're going to have a large amount of soybean meal available to us. And we've had a lot of questions around net energy and the energy value of soybean meal, and is it similar to corn? And so there is conversation that there is a potential that soybean meal could actually replace part of corn in diets for energy. And so we are playing around with some very high diets of soybean meal and looking at those relationships in terms of gas emissions and where that could put us as an industry, right? Because again, if we're going to be doing this as we go forward, the question is, how are we going to control it, right? If soybean meal is high and we know nitrogen excretion is going to increase, we know ammonia is going to increase, how are we going to manage it? So this is a very small study. The negative control here is actually the high synthetic or high feed-grade amino acid diet. The positive control is one where we feed extremely high levels of soybean meal in the diet. And so we can see here that when we look at methane production, we see a pretty significant increase in methane production in addition to some other things. Now, in our study, we were feeding pigs that were about halfway through their grower phase, and we did not see the change in hydrogen sulfide that we would have expected to see with that crude protein shift. And we didn't really see that shift here either. But we are playing around with different enzymes, and that's what all of these are, to try to better understand how we can start to manipulate that odor emission. So again, when we think about some of the advances and some of the things that we're moving forward on, we're not just thinking about what's the lysine requirement of the pig, we're also thinking about how do we start to shift and prepare for sustainability and those conversations. When we also think about the use of crude protein in the diet, we start thinking about what else is happening in the industry. About 3 to 5 years ago, we saw a resurgence of ETEC, so hemolytic E. coli. Couple of combinations here. We had a shift in the predominant genetic population within the commodity pork production that does not carry the resistance gene for E. coli. And so we started to see this, but again, we also saw a change in virulence with E. coli. And so the E. coli itself is actually coming on at a later time in the nursery than what we typically expected. And so what we are trying to do with feed-grade amino acids is really focus in on this non-digestible protein, keeping it out of the hind gut, where we're going to get that fermentation and where we're going to feed that E. coli, potentially cause those problems. And so what we can see is as we shift away from a high-protein diet in the nursery, which is this blue line here, and we look at all the different opportunities here to use reduced protein, either with feed-grade amino acid supplementation or without, we start to reduce the scouring potential of those pigs or the expression of E. coli in the nursery. And so we do recognize that feeding feed-grade amino acids in our nursery does have the potential to improve gut health, which is very important to us, of course, at this time. So I've talked to you a little bit about the benefits of reducing crude protein and the amino acid potential that we have, but there is a point where we have recognized that we can't go as low as we'd like to with crude protein. There is a meta-analysis that was published in 2022 that demonstrates the different levels where we feel like this is where we can probably go as our minimums for crude protein in finishing diets. The ones we tend to focus a lot on in terms of research has been here. We know that when we start to go below 12%, we do see reductions in feed conversion and growth rates. And so the question has always been focused around why is that happening? And the answer is we don't have the answer yet today. We have spent a lot of years. I've probably been working in this area for about 7 years, and I know many others have as well. So groups have looked at adding various things to the diet, right? We've gone through, we've added all the different amino acids that we currently have available to us. We've played around with those ratios. We've tried adding in just nitrogen, thinking we were just low on nitrogen. We've looked at isoflavones being a potential for a growth factor that maybe we were missing. Certainly as we pull out soybean meal, we lose potassium, so maybe it's a potassium deficiency. And we even looked at DCAD, and we struck out. So we are still looking at this and trying to better understand how we can get lower in terms of crude protein and still meet the pig's requirements. So I'm going to leave that on the shelf because I don't have an answer for you today, but I do want you to know that we are considering this and thinking about the fact that we know we have a limit on where we can go in terms of crude protein. So I kind of set myself up today. I have a few questions. I said, well, what's the challenge? Where are we at today? Some of the things that we are talking about when we think about amino acid use is, have we considered the relationship of net energy to lysine correctly? What's the metric that we're chasing? Are we analyzing the requirement needs correctly in trials? And are we considering these interactions of amino acids appropriately? And so I'm going to touch on each of these with some data here and try to maybe stimulate some conversation or thought at least. So the first part here is, have we thought about this relationship of net energy to lysine correctly? And the answer is we don't know. We are, as a swine industry, I still feel we're pretty young when we think about net energy in the United States. Many of us argue on a day-to-day basis about what the appropriate net energy is for any single ingredient and how are we defining it. And so this is one study that was actually presented out of Kansas State where they looked at different phases of production and they assigned a net energy value to soybean meal. And soybean meal is really the one that we're struggling with, I think, the most when we talk in meetings. But when we look at the early finisher versus the late finisher, we do see that when we feed high soybean meal compared to low soybean meal, we don't see much of a shift. But then when we add fat into the diet or when we supplement back with additional feed-grade amino acids, we are picking up a response to average daily gain, both in the early finisher and the late finisher. When we look at feed efficiency, again, we see a similar response here in early finisher, but we don't see that response carrying through in the late finisher. And so when we actually look at the caloric efficiency of the pig in these two phases based on the data that they presented, we are seeing a varied response. So we're seeing a different response here versus here in terms of particularly of our low and high soybean meal diets. And so what they've actually determined is that the net energy value or the caloric efficiency shifts from early finisher to late finisher. And so when we start thinking about net energy is not going to be a constant value. And so if we're going to start looking at amino acid requirements relative to energy, we're going to have to be thinking about how it's shifting as the pig matures. And that is a piece that we do consider, right? So energy is extremely important for our pig. It's the limiting factor for what we do. And we do formulate on lysine energy. Okay, so when we think about formulation, I'm thinking energy and I'm thinking lysine, right? Those are the first two that I think about when I'm doing a swine diet. Of course, lysine's our first limiting amino acid. And so as we go through that formulation, the steps that we first do will be this ratio right here. Because I'm not going to put any more lysine in the diet than what the pig needs to actually utilize it. And so whether we're using ME or NE will sit here. Then we're going to chase this with amino acids related to lysine. And then lastly, what some of us are now starting to look at a little bit harder is other amino acids and those relationships to one another. So isoleucine to leucine types of relationships. And so it leads us to this next question. What's the desired metric? There are a series of studies that are out there that show that depending on what metric I'm using, my amino acid requirement is going to look different. So an example here is the tryptophan to lysine ratio. When we look at tryptophan to lysine, and we're looking here at a young pig, this is in the nursery, and we look at average daily gain, we can see that as tryptophan, here's our tryptophan numbers, as tryptophan increases, we see a nice response in average daily gain. We also see an improvement in gain to feed. Okay, so this is the young pig. And we can say that the requirement for that young pig is pretty high when we think about the tryptophan requirement. As the pig gets to about mid-phase, mid-grower phase, right, we're still putting on a heavy amount of muscle at this point, but what we can see is this shift in average daily gain, the tryptophan kind of plateaus out here, where in the nursery it was a little bit more linear. And so we actually do see that the tryptophan ratio here is going to decline a little bit. And it's going to sit, somewhere generally between 18 and 19. But when we look at feed efficiency, we're still improving feed efficiency out here close to 20. So all of a sudden I have a tryptophan to lysine difference. So in mid-grower, if I'm looking at feed intake, if I'm looking at average daily gain, I might be here. Here. But if I'm looking at feed efficiency, I might be over here. Again, when we think about this as a pig is maturing, right, we're really close here, we're starting the fattening phase, we can see that shift even more predominantly, right? We're probably going to feed at 0.18 for average daily gain, but many of us are going to chase this number over here, which is feed efficiency, so we're going to be at about 0.19. Okay, so how we think about what we're trying to achieve could influence how I formulate that diet. We also look at this in terms of seasonality. So many times, because tryptophan, for example, will drive feed intake, we're going to shift to higher levels. And I didn't show you the feed intake data, but it would look similar, right? So we will see a feed intake response. We might push up. It might be more economical to go to that higher level than what it would be in the wintertime. Another example of this is related to arginine. And so arginine to lysine ratios are ones that we're recently really starting to get narrowed in. And you can see we're doing this in phases, but this is a nursery phase, and I'll show you that data here. One of the challenges that we have is if we go into the 2012 NRC for swine, we don't know if some of these ratios are correct. We feel really confident with lysine and methionine and threonine, but since 2012, we've done a bunch of research on tryptophan. We're doing work on arginine, valine, and so we really don't know if what we see in the NRC is correct because that data is very, very old. And so this was a study where we picked up where we could. We created a diet as low as we could create it for arginine, which was at 45%, and then we went up to 145%. We kept the diets isocaloric and isonitrogenous by utilizing glycine and L-alanine for nitrogen sources, and then we just replaced arginine with cornstarch. Right? So we kept them very, very much the same. And what we saw when we were feeding the different levels, which are listed down here on the bottom, average daily feed intake had a really nice response on these nursery pigs, where what we were seeing was about a 97% arginine requirement. When we looked at average daily gain, again, it looks very similar in terms of the response. And again, we see about a requirement of about 97%. When we shift over to body weight, which was a little bit related to efficiency, what we see here is it shifts a little bit to 101. We have some other data that I didn't present here, but we kind of feel like we're about there for an arginine requirement. Okay, but again, it shifts a little bit as we think about gain versus other metrics. And so how and what metrics are you using are going to be really important. I'm also going to talk a little bit about how we present the product. Okay, so we feel very confident now that we have a good idea of where the arginine and lysine requirement is, but what if we throw in another factor like E. coli? We had done some work in the nursery where we had fed water-based arginine in addition to feed grade. So young pigs, when they're first weaned, they don't eat very well, but they do drink. And so the question is can we start to provide water supplementation of our amino acids and support that performance? In addition, something to think about is we know through a series of research, and you all have the similar research, is that if we can get products into an animal ahead of an infection and give the gut time to really develop, we have a better chance of being resistant to that infection. And so in this study, we looked at two different levels of crude protein. We had a standard level of crude protein in that diet, so what we see in the industry, and then a low crude protein, so high feed grade amino acids. It was about a 2% reduction in crude protein from standard to low. And then we manipulated the diet, we left the diet where it was with arginine to lysine. And then we supplemented additional arginine in the water. And so as the pigs got older, we reduced the arginine in the water, but we gave them a supplemental amount of arginine to come close to about that 1%. And then we exposed the pigs to E. coli. And there's a lot of information on these slides, so I'm just going to pull out a couple of factors that I want you to focus on. So here's where we exposed the pigs to E. coli. They were already on their treatments here. They were already getting their water medications. In fact, when we gave arginine in water early, we did have a little bit of looseness here, but it was not related to the treatment. We had some rotavirus that came in with the pigs, and so they had to clear that out. And you can see they were pretty much similar here at the fecal score before we gave the E. coli. And once we gave the E. coli, there was a delayed response in the shedding. So the shedding didn't occur here until about day 7. We typically expect it between day 4 and 7, but in this case it happened around day 7. And so what we can see here is when we actually had peak fecal shedding, with water supplementation of arginine, we reduced the shedding. We reduced the scours. And so again, this is a demonstration of being able to use amino acids in a different way. to support our animals through a health challenge. In addition to that, we saw some improvements in villus height in the pigs prior to the infection. Okay, so supplementing with water arginine. And again, we saw that in a previous study, so this wasn't surprising to us, but I did want to share it with you because what it's showing is we're setting the gut up a little bit better before we do the exposures. And so here's an opportunity to use feed-grade amino acids in maybe a little bit different way and help us prepare the animal for potential health challenges. Okay, so I'm going to move on, and the next question was, are we using the correct model? And this is one that we have a lot of conversation around in our office. Traditionally, when we think about setting up an amino acid requirement, it's just a 5 dietary treatment type of requirement study, right? We pick the top, we kind of pick where we think it's going to land. That's going to be like diet number 2 or 3, and we're going to look for the break point, and that's going to be our amino acid requirement. We've done those types of studies for years. It does require that we have some kind of idea of where we're going to be so that we can ensure that we get that appropriate break point in our data. But we've been looking at some other opportunities, right? I think it's very easy to use breakpoint analysis for things like your first couple limiting amino acids. For us, lysine, methionine. But what happens when we start thinking about branched chain amino acids? Branched chain amino acids work together. Valine, isoleucine, and leucine are not separate amino acids. And we tend to see people trying to define leucine to lysine ratios, and those are different than the isoleucine to lysine ratios. But when you have 2 amino acids that actively compete against each other within the gut for absorption, how do you create breakpoint analysis? You can't, is the answer. And so we moved on to something called a central composite design. And my graduate student, who's much smarter than I am, developed these images for us to kind of follow. But really what it's trying to do is, instead of looking at a 2-way, it's looking at 3-way factorial type of responses. And so it allows us to start to look at these interactions in a little bit different way as that animal starts to absorb those amino acids. And so here's just a little example of a central composite design that we used in a nursery study. And I'm not going to try to explain it too much, but what we did is we assigned a value, and we had actually 15 treatments. So we had these 5, we call them values here, and we have the 3 amino acids that we were looking at. And then what we did is we created kind of a logarithm. And so we might have one dietary treatment that was minus A, and so that meant this was the ratios within that diet. We might have had a dietary treatment that was minus A, minus 1, and 0. So minus A would have been 98, minus 1 would have been 50, and 0 would have been 65. And so we looked at all the different pairings of those 3 values, and we created those 15 diets. And so again, we kept them isocaloric. We used cornstarch to replace our synthetic amino acids, and we ran the study. And so this is just in one phase of production, and we know that this could change as the pig gets older, but it creates some really unique conversation pieces. What I'm going to tell you is we recognized in the study that regardless of what we did, if valine was not correct, we lost the response. Okay, so valine was the driver in this whole conversation, and you can see that here. Valine is significant. To kind of give you an idea, because these numbers are a little small, what we have on this axis here would be our leucine to lysine, and then over here is our valine to lysine. And then we have others where we might look at isoleucine to lysine and so forth. So we're looking at the relationships, but as you can see, this is 3-dimensional. And so how we look at these types of graphs would be here. So at the bottom, when we look at leucine to lysine, as leucine goes up, right? So as leucine goes here, and the valine to isoleucine ratio, or sorry, the valine to lysine ratio comes down. So as we lose that valine to lysine, our average daily feed intake is the lowest it could be. But when leucine to lysine levels are lower and the valine to lysine levels are lower, our average daily feed intake is improved. So it starts to help us understand that if I'm going to change the ingredients within my diet and these ratios start to shift, I can start to predict that response based on those relationships. Okay, so that's average daily feed intake. If we look at average daily gain, we've got a little different situation at the bottom. So this is leucine to lysine. And in this case, we've got the lowest number to the highest number. And then we have isoleucine to lysine, and this is 50 on up here. And so when we are at our lowest point here, our isoleucine is at its lowest, and the leucine to lysine ratio is at its highest, right? So they're actively competing for that point, and we're losing gain. But if we want to recover gain, we're simply going to drive leucine to lysine to a lower ratio and let isoleucine stay, and we can grab that gain right back. Okay, so we also see it on feed efficiency. Feed efficiency actually looks a little bit bimodal, so we can pick those responses up again when we look at leucine to isoleucine. But again, the whole point is valine is significant. So if valine's not where it needs to be, we lose some of these responses. And so from that type of a model, we're able to come up with prediction equations. And so we actually now have this on our extension website for producers to play with. And so you can go in and say, well, if I'm looking at a pig at this weight and I'm feeding these levels of these 3 amino acids with those relative ratios to lysine, here's the predicted performance I'm going to get. And then as I shift, in this case, if I shift isoleucine up, we're going to pick up a response in average daily gain, feed intake, and gain to feed, and I can start to predict those parameters, right? And so we can use that slider, and it's going to look very similar to those models that we just showed you. But it gives us the ability to start to think about those relationships and being able to predict what's going to happen, and maybe some lower level amino acids that we don't always think about. Okay? But there are some challenges with this concept. Okay, so what I've been showing you is in a growing pig. This pig is putting on high amounts of lean, is actively growing, but what happens in the reproductive animal who's mature? So we took the same data, and this is not public yet, it will be next Midwest, but we took the same data and we looked at lactating sows, and we looked at piglet performance. So we looked at milk yield, we looked at growth rate, and we looked at mom's ability to consume feed. And we took, because we did not have the ability to do 15 diets in a sow farm, we took just 6 of the diets that we felt had the greatest impact or potential to impact that sow based on that nursery work. And so we had diets in here with a valine to lysine ratio that's low enough that we would have expected a reduced feed intake of the sow. And when we got done, when we got done, there was no response to feed intake. She did not change. She did not respond to the dietary treatments the same way the nursery pig did. And we somewhat anticipate that because the sow has a great ability to buffer anything that's happening within herself and still provide to that piglet. But the interesting concept that came out of this was this. So if we look at this data, and I know it's hard, it takes me a while to look at it, so we're just going to talk about a couple of points. If we look at this as feed intake and we say, here's all the branched chain amino acids in that diet, what did she consume? We would anticipate that the diet that has the highest ratios of all 3 of these would have the greatest amount of branched chain amino acid intake, and it does. Okay, this is significant here, right? It follows, there's a pattern. This is our lowest, and so this is in fact our lowest total branched chain. But when we pulled blood from these sows and we looked at circulating levels of branched chain amino acids, we don't see the same pattern. So the diets where we fed high amounts of synthetic or amino acids and high ratios now all of a sudden aren't the top, right? This diet that was intermediate has the greatest level of circulating branched chain amino acids. So the question is what's happening? What's happening within that animal, and that's where we're at today. So our student will be doing some surgeries this fall and be actively collecting blood and marking these amino acids, and we'll be chasing them to see. More than likely in this situation, the sow is using these amino acids for energy. And that's exactly what we do know from other data, is that these amino acids, these branched chains can get converted to energy, and the mammary gland is likely consuming them. But we find it interesting that these different ratios are influencing the circulating levels. Okay. So another question that we have is, are we considering the interactions appropriately? And so we just demonstrated that with the branched chain amino acids. And so as we look forward, one of the questions that we now have, and Dr. Hayden down there, I can blame him for this conversation, is what do we do with these other amino acids that have these unique relationships? So he's challenged us to create a phenylalanine and tyrosine study, and it doesn't fit the central composite design because they're not competing against each other, right? And so we're now looking at a 4-factorial design that builds off the central composite design that allows us to start to look at these relationships, because these are definitely unique. And so that is where we're looking at when we talk about what's next, will be these, right? I don't have any data today, but when we start thinking about where are we at in sow amino acid research, some folks are doing histidine research today, so we're already moving into histidine. And then we're now moving into these other amino acids and these unique relationships. In addition to this, one of the things that we always want to keep in mind when we start talking about amino acid research is we can predict, we can come up with the requirements, but at the end of the day, where's the economic point? And so what we typically see today with our nutritionists is that when we think about that requirement, if we say the requirement is here, they're likely going to feed here. So we generally will feed about 95 to 99% of the requirement simply because the animal doesn't tell us any different. There's enough variation within the barn that we can feed a little bit below the requirement and keep the economic piece in mind. But at the end of the day, our goal is still to find those requirements so that our nutritionists in the field can set their appropriate economic return. So really, in conclusion, where I'm at with this is that we're going to continue to better understand these amino acid requirements. We're going to continue to look at the different phases of growth, because it's not just, oh, in the nursery this is the requirement, so it's the same for the pig throughout. That's not the case. We also have to keep in mind that different metrics are going to influence potentially where we're going to set that requirement. As we continue to focus on sustainability, we're going to continue to look at how we manage the nitrogen that's coming out of the pig, to work towards gas emissions, as well as life cycle assessments and nutrient resourcing and recycling. We're going to continue to work on new models to start to predict some of these requirements as we get further and further down the chain of our amino acid list. And really, that's kind of where we're going to end up. So with that, I want to thank my students who aren't here today, who've done a lot of the heavy lifting of some of the data that I shared, as well as the support of CJ Bio that they have provided over the years, as well as a few other groups there. So with that, I want to thank you for your attention.